So I'll be talking about seal, and let's start with a problem. So, many lights, sorry. So let's start with the problem. Basically, it's very hard to use encryption with Web3 today. You have many problems. For instance, where do you store the keys? You can store them locally, you can store them on centralized solutions, or you can store them on custom infrastructures that are usable for specific apps, but there is no common way for storing those keys. And even if you have a place to store those, it's not clear how to define access policies that are Web3 native in a sense, that are dynamic and depend on something that is defined on-chain. And the third problem is that you don't have a specific type of encryption that you can use for all use cases. For some cases, you need something like RSA. For other use cases, you need something like El-Gamal with some variant of zero knowledge or whatever. And even if you have a solution for one key type, you don't necessarily have solutions for other key types, okay? So let's go over a few use cases that we have in mind to make sure we are all aligned on what we are talking about. So obviously the first one is I want to encrypt something that only I could access. That's the simplest one. The next example is I want to encrypt something and share it with someone else, right? I want to send an encrypted message. I want to share a file with my boss. So it's one-to-one. Next step is I want to share something with a small set of parties, for instance, my friends, my family. So there is a limited set that I define somewhere, and I share any content with that group. The next, and starting to get more interesting, is a case where I don't necessarily control who would have access. Basically, I sell access, so I give access to my data to whoever has, for instance, some NFT. So it's basically unlimited access. Unlimited number of users can have access to that content. And the last use case that I want to mention here is the use case where I want to say that everyone can have access to those keys after some event occurs. For instance, after some time has passed or something happened on-chain. So basically, it's a way for me to share access to everyone after some event, okay? And all those use cases are use cases that we are interested in when we talk about encryption. So that's the background of why we introduced Seal. So Seal is a solution that gives you a way to encrypt and decrypt data using policies that are defined on-chain, Web3 native, and it's easy to use it together with Walrus, with Sui, with other components in our ecosystem, Nautilus, and others. So in very high level, Seal has three components. The first one is what we call decentralized key management, which is a key server that is an off-chain service that holds a key. It's a very lightweight service that holds a key, and basically users can interact with that service and ask the service to derive the key and give that to them so they can decrypt the data. However, the policies are defined using the second component, which I call the programmable access control. Basically, those are move functions defined on Sui. You use move for that. You can use the same object you use for your application logic. You can use the same toolchain for testing those functions. You will see example where we can use any object defined on Sui for those policies. And based on those policies, the first component, those off-chain services, basically provide access to the keys to users depending on those policies, okay? The third part is what basically the glue between the first two we saw is the SDK that is running on the client side. That part provides encryption and decryption on the client side, and you can encrypt. It is oblivious to where you want to store the data. So you encrypt your data. You can upload it to Walrus. If it's small, you can upload it directly to Sui or other places. And it allows you to decentralize the dependency on this off-chain key management server that I said the first component by basically picking n such key servers in a way that you need some threshold of them to collude in order to be able to recover the key. Okay, so that's the T out of n threshold decryption that it supports. Cool. So let's talk about how. So the next step, let's see how we encrypt using seal. So in this example, everything starts from the dApp itself. Okay, so the dApp basically knows which policies it wants to use. So we have the package with the policy from Sui that is deployed on Sui that defines the policy on which the dApp wants to depend. And also we have a registry on chain that says for each key server what public key that key server has. And given those two inputs, the dApp can use our SDK to basically encrypt any message, any data, to depend on those policies. It's a bit vague for now, but basically to depend on those policies and on that public key, and using something we call key ID, which is basically a key that is associated with the policy that is defined on chain. So given all those inputs, you use the SDK to encrypt the data, and then you can, as I said, to publish it on Walrus or elsewhere. So that's the encryption part. The decryption, and as I said, basically you can take any set of n key servers and any threshold and encrypt your data in a way that requires more than the threshold to recover to be able to decrypt the data, as a way to decentralize as a way to reduce the trust on those key servers, basically. Okay. Great. So let's see how the decryption works. This part is a bit more involved. So the dApp, so we call the dApp is the component that wants to interact to show, for instance, your movies on the website. So that is the component that wants to see the data. So it asks the user to confirm access to the decryption keys that the user can access, okay? Because otherwise, any dApp can steal those keys. The user confirms access by basically signing in the wallet, saying, I'm willing this dApp to access the keys, and those keys are limited only to the keys that are associated with the specific package, okay? So a malicious dApp cannot access all the keys in all the different keys you have access to as a user. Once the dApp receives those keys, that approval, it constructs something we call a session key that allows it to retrieve multiple keys from the backend for this specific package with those policies. And now the dApp can interact with the backend. This is step 3 here, where the dApp basically said, I want to have access, I want to retrieve the key that has this identity called the K in this case, okay, for this specific package. So there is, again, an identity that is associated with the policy. What the key server would do, it will check on-chain using the latest state of the blockchain whether the user should have access depending on the policy that is associated to that identity. And we will see in a second how to define those. If the policy says that the user should have access, then the key server would derive and return a key to the dApp. And then in the last step here, the dApp can retrieve the file from Walrus or from elsewhere and decrypt the content and show it to the user, okay? So this is roughly the process. And as I said, the session key can be used for retrieving multiple keys. So the user only needs to confirm once, providing access to his keys to the dApp. And if you're using, for instance, you want you're using a dApp that shows you movies, let's say Netflix on Walrus, then you just need to approve one access to this dApp, and from now on, the dApp can retrieve all the files, the decryption files for you and show it to you without further user interaction. Okay? Yeah, so this is about the decryption. Let's see a few examples of policies. So here we have what we call account-based access, which is the simplest policy. Basically, I want to say that account X should have access to this key. That's it. So I can use that to encrypt my files, to store my files, and only I should have access, or I can set it to a friend of mine by encrypting the data for his account. Okay, so the key ID that I would use here, again, key ID is just a string, an identifier that is used inside our system to basically to associate it with an actual key. In practice, we use something called identity-based encryption, if you're familiar with that primitive. But for this talk, you can think about there is a key that is magically generated by the system and is associated with that identity that we see here. So what this policy would define basically is that for requested ID, the first parameter you see in this function, this is the ID that the user is requesting access to. And we have here the transaction context. We simply check whether the caller, we retrieve the caller from the transaction context, we check whether the caller is actually the requested ID, okay? And only the right caller with the same account X would be able to finish this, to complete this function without the assert to fail, okay? So this is a very simple account-based access, and this lets you already do nice things like uploading and storing your own files, your own data, or sending to your friend. Let's see a more interesting example, allow list. So allow list is a simple move object with a list of users that are in the allow list. There are APIs somewhere that let the admin or someone else to add and remove users from that list. Let's ignore that part. And the way you would use this allow list is you would use the ID field of the allow list, which is unique on Sui. That's the object ID. You would use that as the ID to encrypt your file. So you can encrypt your file using that ID, using the SDK again. And whenever decryption is required, the function we see here is called to check the policy. And this function retrieves, again, the first parameter is always the requested identity, key identity. And then here we see that we also receive a specific allow list. You can see that we can use here any Sui object, in this case, the allow list that we just defined, and again, the transaction context. And what this policy would check are two simple checks. Basically, we check that the requested ID is indeed the ID of this allow list that we received in the function call. And secondly, we check that the context caller, the sender, basically the user that asks to retrieve the key, is indeed in the whitelist, okay? Two simple steps that are tested here. And again, if this function doesn't fail, the caller received the key. Great. So using that, for instance, we can implement something similar to what we saw, the gated access using it. Instead of NFT, you just update the allow list with the users that need to have access to the keys. Great. Let's see a third example. I will just mention it very briefly. You can implement what I said about encrypting to, for instance, to some events. So in this case, you can encrypt to a time, for instance, tomorrow at 1 p.m. And the policy will simply check whether the requested ID is, when you convert it to a time, is a time in the past using the current time on seal that we retrieve from the clock objects. Okay? So you can implement sophisticated things using any object that is available on Sui. Great. So we launched Seal on testnet last month. And currently it provides the things that I mentioned. Those are basically client-side encryption and decryption using the SDK. You can use threshold, pick any set of end servers and any threshold T and use them when you encrypt your data. And you can use the decryption both off-chain using the SDK, and we have the option also to do decryption on-chain. If you want to do something like secure voting, when you want to send the encrypted votes on-chain, and after some time reveal all of them and find who is the winner. So you can do that using the on-chain decryption. And as for the next steps, we are thinking about things we can improve with our developer experience, adding more features like post-quantum encryptions and other. But obviously, we are looking forward to your feedback We want to learn more about your use cases or use cases you have in mind and you think you are blocked for things that are missing. Any feature we can add to this, please reach out to us, either here at Basecamp or on Discord. Happy to talk. And with that, I'm done.